So the first question I have about this first page is that equation the same thing that I gave you? Yeah, but it doesn't look like anything I gave you. So why not? How can I compare this to what I gave you? Go ahead, Danny. Yeah. Right. So they're just instead of defining P, they're putting MV together, right? So if you think of MV as P, it's the same equation, right? So it's just a different way of looking at the same equation. All right. Now, here's what I want you to tell your partner. I would like you to discuss with your partner explain why it is important for a golfer to follow through on her swing. All right, so tell your partner what you think based upon the reading. Why is it important for a golfer to follow through on her swing? All right. Camille, what do you think? What are you trying to do when you're following through on the swing? All right, so you're putting momentum into the swing. That's true. I'm going to say that the key, though, is if we think about at least from the perspective of the ball, what we're trying to do is we're trying to give the ball as much momentum as possible. Connor, what do you think? What do you think of this one? No? Didn't see anything from the reading about this. What do you got, Frank? Yeah, what's the point of following through, right? The point of the following through is to increase the impact. So if I go back here to what we said here, right? To increase the momentum of an object, it makes sense to apply the greatest force possible for as long as possible, right? Because you need as big of an F as you can get and as big of a T as you can get, right? And so when you follow through, the point of following through is you're extending that time of contact, right? So if you take the same force, but you can apply it over a greater amount of time, you can cause a bigger change in momentum. All right. Before I have us read on there, I have another couple questions I want you to consider. These aren't directly from the reading, but they're just questions to think about. So let me go back to this one. So if you go back for a second, 4 questions here. Which has more momentum, a 1-ton car moving at 50 miles per hour or a 2-ton car moving at 25? Does a moving object have impulse? Does a moving object have momentum? For the same force, which cannon would impart a greater impulse to a cannonball, a long cannon or a short cannon? All right, so here's what I want you to do. I want you to take, there are 4 questions there. I want you to discuss those 4 with your partner. Each one, what do you think? All right. Which has more momentum? A 1-ton car moving at 50 miles per hour or a 2-ton car moving at 25? Here. Rachel, what do you think? Yes. Why are they the same? Yeah, you're right. It equals out, right? The equation is mass times velocity, right? So if you take the mass, these aren't the units we're used to, but if you take the mass of 1 ton times 50, right, it's the same as 2 tons times 25, right? So if the mass goes up, but the velocity goes down the same amount, it's the same momentum. All right. Does a moving object have impulse? What do you think, Gavin? Yes and no. Tell me why.
Like if a car doesn't have impulse because you have been driving it, but if you have something, you have, wearing an object like a chair or a wheel or something.
Okay, so that's interesting.
Actually, I take that back because, I could hold that. Never mind.
I'm sorry. So what's your answer?
I don't really know.
Fair.
The answer is.
I want to say you said something interesting here, which you talked about a car, right? And you talked about how a car might have impulse. What was your thing? You said because of an engine. Why is it important? Why is the engine important?
It's giving me drive.
Force, that's the key, right? To have impulse, you have to have force and a time, right? But when we're talking about impulse too, right, impulses changes the momentum. So you can talk about the car, the engine of a car, applying the impulse to the car. When I talk about the car as moving though, right, the car is moving. If it's moving at a constant speed, it's going to have no change in momentum. So I'm going to say that if just because an object is moving doesn't mean it has impulse. If it has force and time, it has an impulse. But just because it's moving doesn't necessarily mean that it has an impulse. All right. Next question. Does a moving object have momentum, Olivia? Yeah, right? Momentum is mass times velocity. So when I talk about things that are moving, they do have momentum. They don't necessarily have an impulse unless there's a force and a time. All right. Anyone want to try for the same force, which cannon would impart a greater impulse to a cannonball, a long cannon or a short cannon? What do you think? Go ahead and tell your partner, if you're not ready on number 4, tell your partner real quick, which cannon would impart a greater impulse, a long cannon or a short cannon? Grady, what do you think? Why? Okay, fair enough. It would give it more momentum. If we think in terms of the definition of impulse, though, impulse is force times time. What are we giving it? Force. Longer time to get barrel. Yeah, we're giving it longer time. If it's the same force, a longer barrel would have more time, right? So it would have more impulse. Okay. All right. So there we go. Go ahead now that we've gotten that out of the way. Go ahead and read page 2. So this is the page that says case 2, decreasing momentum over a long period of time. Read this section and then we'll talk about it here in a moment. Okay, with your partner, there's this diagram that you see on the reading. What is this diagram attempting to convey? Why is the diagram there? Tell your partner what you think. Hey, what's up, Lee? Bathroom. Yes. Right. Scott, what do you think? Not really too sure. Well, let me ask you this. What is different about hitting a haystack? Okay, so yeah, let's be clear. It's not necessarily that you're making contact, at least not in the same way as you are with the wall, right? You're still making a contact, but you're not making a contact with the wall all at once. I think is the key, right? Let's see here, Stephen, you want to add anything to this? What do you think this is trying to convey? Yeah, the difference between a haystack and a wall is how long does it take you to stop, right? You got a haystack, right? The goal is you can increase the time of the collision with the haystack, right? Whereas if you hit the wall, you have a very short time of impact. And so if you have a short time of impact, you need a big force. Because who needed more impulse? Do you need more impulse to hit the haystack, or do you need more impulse to hit the wall? Let's think about what impulse is, right? Impulse is change in momentum. Who changes momentum more? How about, what do you think? Say again? The haystack, it seems like the haystack has more impulse, but I'm going to say it's not the haystack that has more impulse. I'm not even going to say it's the wall, right? The key is they both are moving, and so in both cases, right, you've got the truck that's moving, and then the truck comes to a stop, right? So which one changes momentum more? If they start at the same speed and they end at 0, which one changes momentum more? Neither. They're the same. It's the same impulse. But the question is, how do you want to get the impulse, right? Do you want to get the impulse through mainly time or through mainly force? Time does not hurt, right? Forces are what hurt. Time doesn't hurt, right? So you have an impulse that you have to get to come to a stop, right? The question is, can I decrease the force of that impulse? The way I decrease the force of that impulse is by increasing the time. What is the application to the egg lab? What do you say, Olivia? Yeah, if it hits the floor, it happens too quickly, right? Mm-hmm. So if you're dropping, let's assume that you didn't have a parachute. If you didn't have a parachute and you're dropping your egg, right, your impulse has to be the same no matter what, right? Because you have to go from moving to stop, right? Moving about the same speed to stop. Do you want to do that? You want to achieve that impulse with mainly force or mainly time? If you're trying to protect the egg, you're trying to increase the time so that you decrease the force. The other way I like to explain this is I like to think about if I were to slam my head in the table like this, right? Watch carefully. If I slam my head in the table like this, so if I slam my head in the table like that, right? Why would that hurt? I'm good. All right. So why would that hurt? Why would that hurt more than slam my head to a pillow? Right. It's the time, right? You got less time if you hit a hard surface, right? If you hit a soft surface, that increases the time so that you don't need as much force.
It also increases my blood pressure.
All right. Go ahead and read that last page now. Let's start with that diagram there, right? Ever heard of the idea of riding with the punches, right? The idea of if you've got this boxer in A is better off Y. Right, Scott? Right. If you are going back, right? If you go back with the punch, the idea is you're increasing the time that it takes the fist to come to a stop, right? Whereas if you lean in, I mean, it's just common sense, right? That you wouldn't want to lean into a punch. But why is that? It's because if you lean in, you're decreasing the amount of time it takes for that punch to occur, right? If you decrease the time, you're going to increase the force, all right? Well, maybe.
Well, you know what?
You would probably also break your face, though. All right. There are 4 checkpoint questions here at the bottom. So I want to start with that first question there. It says, this real quick. It says, if the boxer is able to increase the duration of impact, so that's the time of impact, to 3 times as long by riding with the punch, by how much will the force of impact be reduced? So right, in other words, it's saying, if I multiply the time by 3, what's happening to the force? See with your partner if you can figure out what the answer to that is. So look at number 1 with your partner, see if you can figure out the answer to the question. Looking for a number, right? I'm looking for a number. If I have 3 times the time, what happens to the force? Thomas, can I ask you what you think? If you have 3 times the force, or sorry, 3 times the time, how much is the force? Say again. Well, so think about this, right? This is saying, like, imagine that you've got, let's say, for the sake of argument, right, that I've got 1 Newton of force, and I've got 1 second of time, right? If I did that wrong over here. Let's say I have 1 Newton of force and 1 second of time. If all of a sudden I triple my time so that I have 3 seconds of time, how much force do I have? Not a triple, 1/3 of a Newton, right? Because here's what this is trying to do, right? The idea of these diagrams here is it's trying to say if one number goes up, the other number goes down, right? That's why it's showing small f, big T, small or big F, small t, right? There, it's the inversely proportional sort of thing, right? If time goes up by 3 times, right, the force can go down by 1/3, right? You have 3 times the force, you get 1/3 of the time, and vice versa, right? So with that in mind, tell your partner what you think about 2. So 2 is talking about if the boxer instead moves into the punch so as to decrease the duration by half, how much will the force be? Okay. Tell your partner what you think for 2. All right. Gabe, what do you think?
Yeah.
Yes, how much greater? So the time goes to half, force goes to how much greater? 2 times, right? Because if this one goes down, so again, the idea is if my time gets smaller, half as small, then my force has to get twice as big, right? They go in inverse directions, all right? Number 3 is, we're going to end here with number 3. A boxer being hit with a punch contrives to extend the time for best results, whereas a karate expert delivers a force in a short time for best results, right? So we're saying that for the boxer, right, we were saying that the boxer wanted to ride with the punches to increase the time of collision. But then the reading says that the karate expert wants to increase the time of collision. So this was, decrease, right? So in this case, we wanted to increase the time of collision. In this case, we wanted to decrease the time of collision, right? Why? Why do you want to increase the time of collision here, but decrease the time of collision there? Tell your partner. Ron, you got an idea? Why do I want to increase time here but decrease here? Lee, what do you think? Yeah, that's the key, right? If you're getting punched, you want to decrease the force, right? So decrease the force, you get bigger time. If you're trying to break bricks, right, you're trying to increase the force. So if you increase the force, you want to decrease the time. Okay? Questions about this? All right. Let's just bring this full circle. I want to go back to this and compare this equation to the egg drop lab, right? We already talked about what a cushion does, right? A cushion increases the time of collision to decrease the force. If you had a parachute, what were you trying to do with the parachute? So talk to your partner about this, right? So again, one more thing, a cushion was trying to increase the time. If you put a parachute on your egg drop, what were you trying to do with the egg drop? What was the purpose of a parachute in terms of this equation? Tell your partner what you think.
So we have less momentum. Yeah. I'll be honest.
All right. Shelby, what do you think? What was the purpose of a parachute?
Oh, because the parachute gives you more time than the force is smaller.
So that's interesting. We couldn't think about it that way. Let's be clear about what we're talking about with the force, though. The force that breaks the egg is not the force of the fall, right? It's the force of the ground. What do they say? They say it's like, it's not the fall that'll kill you. It's
Not the ball, it's the
yeah, that's right. Yeah, so it's right. It's not the force of the fall. So it would be tempting to say that what you're doing with a parachute is you're increasing the time, but you're not increasing the time we're talking about here, right? You're not increasing the time of collision. You're increasing the time of the fall. So let's think about that. Is there something else that Maddox, that the parachute is trying to do? Slow it down, right? It's trying to slow it down. In this equation, if I'm slowing it down, what am I changing in this equation? No, not the time of the collision. I'm changing momentum, right? If you're going slower, you don't have as much momentum, right? So the idea is, as far as the egg drop was concerned,
There's not such a big change in
right, that's right. As far as the egg drop was concerned, by and large, the two strategies were cushion, which would increase the time, and or parachute, which would decrease the momentum so that you wouldn't have as big of a momentum change. All right. Question about this? All right, so that's the basics behind impulse and momentum. We will start talking about how to do calculations with that next class. All right. What we're going to do for the rest of time, like I said, is I'm going to give you a little bit more time to do research on your projects. But let me just share a couple things real quick. So go ahead and get out your computers. So there should be a project sources assignment in the timeline now. I've got it set to be due on Friday. And you already, hopefully you're pretty close to this. This is actually not what yours looks like. Just a second. Yours looks like this. So after your test on Thursday, you got started. It wasn't Thursday. It was Tuesday, Monday. Whenever you took your test, right? After your test. You started researching things, right? And I told you to have resources and to have a summary of what you were getting from each of those sources. And I talked to about half of you that day, I think. I stopped around here somewhere, right? Did I talk to you about your sources last time? Okay, Max, did I talk to you?
I wasn't.
Okay, so I stopped at Danny then. All right, so I'll talk to you about your sources if I haven't yet. But the key was to find 3 sources, and at this point you just kind of summarize them. And right now you're just learning about your topic. You're not necessarily working on your presentation yet. You're just working on the topic, and you have a Word document where you're summarizing 3 sources. And the thing that you couldn't do yet was you couldn't do your summary, or sorry, your works cited. So I want it to be cited in APA style. The reason we do APA style is, and not MLA, is because it's a science project and not an English project. MLA means Modern Language Association. It's for English projects. APA is American Psychological Association, but it's used for more science projects. Yeah.
Can videos work too?
I will allow you to have, I want you to have at least 2 non-YouTube sources. But yes, you may cite 1 YouTube source. So I just want to show you real quick the easiest way to do APA style. If you used Mrs. Young's research page, which I should have linked to here, but if you need to link to it, it's in the Culminating Project folder. It's right there if you need it, right? But if you used her research page and you used one of these 2, it does a citation for you. So like if you were researching black holes, for example, well, if it'll work. But anyway, if you were researching black holes, and you decided that this is probably not a good source, but you decided this was the source you wanted to use, right? You can go to here that says cite, and you can just copy and paste the APA source directly into your Word document, right? So that's easy. You could do something very similar if you use student resources in context. If you used any other website, I suggest you use this thing called Scribr. So you go to this thing called Scribr, you would say, I'm using this website, and you would fill in what's the title of the website, what's the URL, all this information. Then you click Cite, and then it would give you, so this is one I did earlier, it would give you the citation, and you could just copy and paste it into your document. Now, I want to caution you, avoid, it has this thing where it will automatically, you can enter a URL and it will automatically scrape that page and get the information for you. In my experience, this does not work very well, right? It doesn't get the information you need very well. So do not use this. Do not use the automatic citation URL thing here, right? Instead, actually manually fill out these forms and then click cite source, right? So again, by Friday, you would need 3 sources. You need a short summary about information you're going to get from each source that's in your own words. And then you need them cited in an APA style. And then you can just upload them right here when you're done. Hopefully, you'll be almost done today, if not all the way done. And like I said, the final thing is due on Friday. Okay. Questions? All right. Yeah, I'll come over there in a second.